Hey guys, welcome back to another calculus video, the last calculus video for the semester. Woohoo! Yeah, I don't know if you're more excited or me, but anyway. We're jumping ahead to section 6.2. We've talked a little bit about the idea of area underneath a curve. Just to remember here, the area in blue underneath the curve f of x between a and b is given by the integral from a to b, the definite integral from a to b of f of x dx, just to remember that that's what we have. So now we're going to talk about a more general idea of area. So let's say we have two functions, f of x and g of x. And so the area here, this blue area, I'll write it in blue. The blue area, I'll call it area 1, is integral from a to b, f of x dx. We just mentioned that. How about the red area down here? This is a different function, g of x. And so the area 2 here is the integral from a to b of g of x dx. Okay, so we have this area and this area here. Well, what if these two graphs are on the same set of axes? If they're on the same set of axes, then we can talk about the area in between the two curves. I'm going to color it in green, the area in between the two curves. So what is this area in between the two curves? This area between f and g is all the blue area minus the red area, right? If you go back and look at these, you take all this blue area and subtract the red area, you'll be left with the green area in between. So if I want to find the area between f of x and g of x, notice f is on top, and then it has to be on this interval from a to b. If I want to find that area in between, how do I do that? This area here is just the top area minus the bottom area. And since integrals are linear in nature, what that means is that you can separate or put together over a plus or a minus. We simply do f of x minus g of x dx. And if you want to think of it this way, the area between two curves is given by the integral of the top curve minus the bottom curve. And we'll talk more about what that looks like here in a little while in different scenarios, but that's basically it. Okay? So as an example, find the area between the two curves, f of x equals x squared plus 3 and g of x equals 1 minus x on the interval from 0 to 2. So I've given you the a, I've given you the two functions. Please note that there's no guarantee that the first function I give you is the top function. It's not necessarily f minus g, it is always top minus bottom, okay? Well, in this entire section, guys, you guys have graphing calculators. I highly suggest you graph on your calculator or use Desmos or something every single time and sketch the graph. So here's what the graph looks like. We've got our parabola function in blue, this is f of x. We've got our linear function in red, this is g of x. And then we've got our bounds here and here with these black dotted lines here. So I'm looking for this area. That's the area that I'm looking for. Obviously, it's a funky shape. It's not a geometric area that I can find using, 1/2 base times height or something like that. We have to use the formula, the integral from a to b of the top function, and between a and b, from here to here, clearly the blue is on top, and so this is f of x first minus g of x. It does not matter if this goes above or below the x-axis. That doesn't matter anymore. What matters is that you have the top minus the bottom, okay? So let's take a look at what that looks like. The integral from 0 to 2 of the top function, x squared plus 3, minus the bottom function, 1 minus x dx. So before we do anything, we want to simplify inside the parentheses. We get x squared. 3 minus 1 is plus 2, minus negative x is plus x dx. Now we just integrate like we've been doing for the last couple of weeks. The antiderivative of x squared is x cubed over 3 plus 2x plus x squared over 2. Evaluate that from 0 to 2. So plug 2 in everywhere. All right. Take this, then you subtract when you plug in 0 everywhere. Now, in this case, when you plug in 0 everywhere, you get 0. This is all 0. All right, that doesn't always happen, so make sure you do plug it in. But in this case, I get 8/3 plus 4 plus 2. All right, and so that turns out to be 26 over 3. Okay, simple enough, and that's the process. Okay, so I want you guys to try this one. Find the area between the curves 2x plus 3 and y equals 1 minus x squared. I have given you the graph once again, but I want you to practice graphing it on your calculator. Make sure that you can do this on your calculator. Don't worry about trying to graph x equal -1 and +1 on your calculator. Just make a note of where those are. But you're looking for this area. So take a couple minutes, pause the video, see if you can find it. Okay, so we're going to do the integral from -1 to 1 of top minus bottom. This time, however, the linear function, the straight line, 2x plus 3, is the top function. This one's on top, this one's on the above, the blue one is, and then the bottom function, y equals 1 minus x squared, it's on the bottom, right? So plug those in. -1 to 1 of the group 2x plus 3, make sure you write it as a group. 1 minus x squared again, okay? And so distribute that out and simplify. You get 2x, 3 minus 1 is 2, minus minus is plus x squared from -1 to 1, dx, and these are certainly easy to integrate. 2x squared over 2 plus 2x plus x cubed over 3, evaluated from -1 to 1. And if you plug the 1 in everywhere, and if you plug in the -1 everywhere, all right, subtracting 2 times -1. Be careful with your signs, guys. Use your calculator for this stuff, okay, and be smart about this. Let it do the work for you. And so here we have 1 plus 2 plus 1/3. Okay, so that's 3 and 1/3. Here we have 1 minus 2 minus 1/3. And so we have -1 and 1/3. And so this becomes a plus and a plus. So we get 4 2/3 or 14/3 is your other way of writing it. Do not give me a rounded off decimal answer. Give me the exact fractional answer. Okay? All right, now, what else can happen? Well, here's a problem in which they ask you to find the area bounded between these two curves, but they don't give you any left and right endpoints. Well, there's a reason for that. If you draw the graph, you'll see that the area is actually bounded between. The two graphs intersect in 2 points. And so we're talking about this area in between the red and the blue. Okay, so just to make sure you guys understand here, looking at the picture, g of x is the red, that's upside down parabola, and f of x is the blue, the right side up parabola. And so the red, this case, is on the top, and this guy's on the bottom during this interval. However, I don't know where this interval is. Now, I can look at my picture and find out, I think that's a -1. I think this is 2.5. Okay, but how do I do it for sure? How do I know algebraically that I am definitely intersecting at those 2 points? Those are my A and my B. How do I know that? Well, you find out two curves intersect by setting them equal to each other. So I need to set x squared minus 3x equal to 5 minus x squared. So this is an extra step that you've got to do. Pull everything to one side. I get 2x squared minus 3x minus 5 equals 0. I factor. I don't expect you to do as quickly as I do, but you certainly should be able to factor. I also expect you to factor it properly. So 2x minus 5x plus 1. And so this gives me x equals 5/2 as my 1 point, and this gives me x equal -1 as the other point. That does match up with what I thought. Now I'm ready to go. Integral from -1 to 5/2 of top function 5 minus x squared, minus bottom function, x squared minus 3x. And once again, I highly suggest that you simplify first. So 5 minus x squared would be minus 2x squared. And then minus minus is a plus 3x dx. And now we can do the integral and solve. So we get 5x minus 2/3 x cubed plus 3/2 x squared evaluated from -1 to 5/2. I'm not going to take the time to evaluate that here, plugging everything in. I mean, you should be able to plug everything in, right? But I'm just going to give you the answer. And I end up with 343 over 24. All right, that is as simple as it gets. Again, do not give me a rounded off answer here. Okay, I want to see you plugging in your numbers and then going from there. All right, so that's how we handle it if they don't give us bounds. If they don't give us bounds. And again, graphing it will help, and you can use your calculator to help you find those places, but you want to show me your work and give me that option to know that I know where you got them, okay? So to follow along with that, here's one similar. Find the area bounded between these two curves, y equals 2x minus 1, y equals 2 minus x squared. Graph it on your calculator, set it up and go. All right, we'll go over it here in a minute. Okay, so once again, I hope you graphed it. Looks like this. And you're looking for this graph, this area right in between. This area right here. Okay, so we need to find these intersection points. One right here. Looks like it's 1, but I'm not sure. This one looks like it's -3, but I'm not sure. How am I going to find it? I'm going to set these equal to each other. Okay, 2x minus 1 equals 2 minus x squared. Take everything to the other side, you get x squared plus 2x minus 3 equals 0. And that factors into x plus 3 and x minus 1. So indeed, -3 and +1, those are our intersection points. And so we're going to set this up. Smallest to biggest always, left to right always. And our top graph this time is what? Our top graph is the upside down parabola. That's the 2 minus x one, x squared one, excuse me. And then 2x minus 1 is the straight line, which is on the bottom this time. Simplify it, and you'll get -3 to 1 of 2 minus -1, which is a total of 3, -x squared, and a -2x. So this is your integral we're going to find. And once again, everything else now is just old stuff. 3x minus x cubed over 3 minus 2x squared over 2. The 2's divide away. Evaluated from -3 to 1. And once again, I assume you can handle this part. Right? Make sure that you group this. Here's the first part minus the second part, 3 times -3 minus -3 all cubed over 3 minus -3 squared. Make sure you use parentheses properly. All right, and if you evaluate that out, again, you can use your calculator to evaluate this kind of stuff, but just understand that my answer needs to be a perfectly good fraction, and I end up with 32/3. Okay, 10 2/3, and that's the answer. Okay, so the last example then is combining the two. All right, we're combining the two problems basically here. We're given two functions, e to the x and 1 plus 4x minus x squared on the interval from -1 to 1. So we're looking for the area from -1 to 1. That's from -1, area in between these two. But then these two curves intersect and then has another set of area here up until -1. So I don't go this far. I don't go all the way until they cross again. I just go to +1 right here. Okay, so here's 1, here's -1, -1 to 1. Okay, but what is the deal? The deal is that they cross, and the bigger deal is that when they intersect, this one goes from bottom to top. Right? This is the upside down parabola. The e to the x curve goes from being on top to being on the bottom. This curve is in blue. So how do we handle that? Well, how we handle it is we think of this as the first area, and that is the second area, and we simply add them together. There's no other way to do it, really, because the top minus bottom always has to play out, and so we have to do top minus bottom. So to find area 1, that's the integral from -1 till, where do they intersect here? They intersect right at 0. That's pretty obvious that that's at x equals 0, and if you plug in x equals 0, you'll see that they both equal 1 there. So that's x equals -1 to 0. E to the x is on top. 1 plus 4x minus x squared is on the bottom. Okay. A2 is the integral from 0 to 1. Now, from 0 to 1, and now the red is on top, so I do 1 plus 4x minus x squared on the top minus e to the x on the bottom there as well. Okay, so that's the setup, and then you do both of those integrals, you plug in for both of those numbers, and then you add them together at the end. Okay, and in this case, obviously with e to the x, you're going to get an e in your answer if you want it exact. Okay, and I'm not going to figure the rest of it out for you. You guys can figure that out and check it if you need to on your calculator, but that's the only different thing that you could have, is if you have to combine that. That's why it's so important, guys. It's so important that you graph every single time, because if you don't graph, if I didn't graph that, I wouldn't know this was in between. Right? I wouldn't know there was an intersection point, and I'd just figure out which one was on top once, and I'd assume it stayed on top the whole time, but that's not the case in this particular problem. Okay, so there's a lot of practice problems. As always, go do those. Check out your My Math Lab, and we will see you later.